and or no employee working on it, it's possible that may happen, which means there are no total participation constraint on either side. Okay? So that's this design. It's really simple, straightforward. Question on this? Okay? No? Now, converting this to relational model, again, it's fairly straightforward if you remember how to deal with one-to-many, many-to-many, and total participation constraint. Every employee set, every entity set goes to a table itself, so you're going to have department, employee, and project. You're going to have that 3 tables. And for the employee table, because there's a one-to-many from department to the employee, you take the key from the one side and place that into many side, which means you take DID and place that into the employee side. There is also a total participation constraint, which means DID must be not null. Question over there?
Yeah, there's actually a step back. How is the sentence, each project has at most 1 employee supported under that project captured here?
It's one-to-many, right? At most 1, which means there are only 1 employee per project.
Isn't that relation about working?
This is 1, this is many.
Sure.
This is 1, this is many, meaning that at most 1, but doesn't mean exactly 1. So there's no total participation constraint on this.
So does supported under the project means
works on? Yes.
Oh.
Okay. And similarly, for the project to employee relationship set, that's a one-to-many mapping. That's a one-to-many mapping means that you take the key from the one side, place into the many side, meaning that you take the SSN value of the employee, place that into the project side. But the difference is there are no total participation constraint here, so SSN doesn't have to be not null. SSN can be null, actually, in this case. Okay, so that's the conversion of this. Any question on this? Good? All right. Moving on to the constraint. Question over there?
Sorry, can I just look at it for 1 more second?
Yeah, sure, totally. And the relationship set between department and project, that's a many-to-many. That goes to a table itself called sponsor, where you take the key from both ends and place that as the user combination of that and the department key. Speaking of which, some of you, when dealing with one-to-many, claim that, oh, the key for employee is not only SSN, but also DID. That's wrong. When you take care of one-to-many, you take the key from the one side and place that into the many side. It's only a foreign key. It's not part of your primary key for that table. Okay. Now, this constraint checking, some of you claim you can enforce this using a table constraint, which is wrong. You cannot do this using table constraint because it involves multiple tables. You have to deal with this using trigger or assertion. Most of you go with the assertion and the simple group by and having check. Okay? There are very slightly variation forms of this, but it should be similar to what I have here. Okay? And you basically say, okay, you group by department and you join department and the sponsor table, and you group by the department ID. You calculate the sum of the projects for all projects. Those money come from different departments. The sum of that, which is the total budget for that project, cannot be greater than half of the department's project. Meaning that all the projects sponsored by that department, all the money I give out, I group them together. I group all the projects sponsored by the same department together, calculate the sum of those projects, that the budget I give to them. The total sum must be, if it's greater than half of my department budget, that's not okay. Meaning that such department should not exist. That's why you use not exist to check this. Any question on this? Okay, good. Now moving on to this dealership relational algebra problem. This one, if you think about it, is almost, if not, identical to the homework 2 problem you had worked on, right? In homework 2, I asked you to show shops, products. Here, I just changed the concept to dealers, customers. It's the same thing. It's essentially the same. The first one is really just a join. I mean, if you cannot get this right, which, you know, this is like really giving you points, right? It's like really trivial. The second one is similar to, there are two problems from your homework that are similar to this. One is, which bank issue more than one credit card? The other one is, for each product, find out the shop that offer it at the lowest price or the maximum price. I forgot which one I asked you in the homework, but there are two problems that are identical to this. If you change the number of visits to price, this becomes exactly the same to that problem from your homework, which shop offer this product at the lowest or highest price. The trick is you do a self-join, and you make sure that, okay, it's different customer to the same dealership, D name equals D name, and one has larger value than the other. The trick, the important, a lot of you get this right, but important is you need to put out the customer name and D name. You cannot simply put out just the customer name, which is entirely wrong if you just put out the customer name. It has to be associated with that given dealer name. And second point, you need to show which one to put out. Do you put out V1 or V2? In this case, you need to put out V2. The idea is you want to put out those who are smaller, meaning number of visits, are smaller than some other customers, which means you have no chance being the customer has the largest number of visits to that dealership. Then you use all the customers who visit that dealership, subtract away those who have smaller number of visits. The remaining one must be the customer with the maximum visits. So it's really, really important for you to specify which one to put out. Imagine if you two put out V1, in this case that would be wrong. Okay? The last one, yes?
Quick question on that one.
Yeah.
So for that one, what, again, give you the insight to project that D name? Because the question asks for the customer name, so I always just assume.
For each dealership.
Okay.
And also, if you only put out the past customer name, what do you get? I mean, I don't think that query actually give you anything meaningful, to be honest with you. Because all you're saying is, okay, one has larger number of visits to the other one, I put out those smaller ones for that dealership. But when you put away the dealership, only having the customer, that makes no sense anymore. Because those are the customers who have smaller number of visits to that dealership. When you put away the dealership association, customer name alone doesn't give you much semantic meaning in this context. Okay. The last one, find the name of customer who visit all dealerships who serve all car model manufactured by GMC. There are two types of mistakes people made on this. This actually is a combination of two divisions. The first level division, find out, from here. Okay, my selection doesn't work. Okay. Anyway, from here onwards, okay, from this bracket, from here to here, what do you get? First of all, you find out all the models manufactured by GMC. That's a simple selection projection. Then you put out D name and model from serve, divide by that. What that give you? That give you all the dealerships serve all models by GMC. It's really, really important that while doing this division, you need to put out D name and model. In other words, you need to put away the price. If you look at the serve table, there is an additional attribute called price. If you do not put away price, you use serve divided by that, what do you get? That's the same as the example I said multiple times in lecture, which is if you use reserve divided by boat ID, what do you get? You don't get all the seller reserve all the boats. You get all the seller reserve all the boats on the same date. Because there's also a date attribute there. I mentioned this like 3 or 4 times. Yet many of you still made that same mistake. If you don't put away price, what do you get? You get dealers who serve all GMC models at the exact same price. Not dealers who serve all GMC model cars. You follow what I'm saying? Okay? Yet half of the class missed that mistake. I only take 1 point off for that, by the way, to show you how generous I am. I'm serious. Technically, it's completely wrong. but I only take 1 point off. Okay, this is despite I mentioned that more than 3, 4, 5 times, and it's open book test. Now you get, and by the way, after this, you do not need to do another projection of dname, because by the definition of division, use dname and model divided by model, you end up with dname itself. You don't have to project dname again. But if you do that, that's fine. But that basically shows me you don't fully understand what division does if you do that. Even though technically it's correct, but it's totally unnecessary for you to do another division after this projection. Because dname and model divided by model, you end up with dname only, the attribute. Follow me on this? Now what do you have at this point? You have a list of dealer names who serve all models manufactured by GMC. Right? And what do you do? What do you do with that? Well, you use visit, put out dname and customer, showing who visited which dealership, divide by this list of dname. What do you get? You got customers who have visited all these dealers. That's it. Who have visited all the dealers of all models by GMC. Again, you need to put out CNAME and DNAME before doing this division. Why? Because there is a number of visits attribute there as well. If you use visits divided by this list of DNAME, what do you get? You get those customers who have visited all these dealers with the exact same number of visits, not those customers who have visited all these dealers. It's much more restrictive than what the question was asking if you do not put out CNAME and DNAME. So a lot of you made that mistake, meaning didn't project away the price in the first division and didn't project away number of visits in the second division. I take 1 point off each division if that's the case. Even though, if you think about it, your division, your query is completely wrong when you do that, actually. But I only take 2 points off. Another kind of mistake I see here is a lot of you manage to figure out this level of division, meaning using visits, the projection of CNAME, DNAME, and the visits divided by a list of DNAME. But the list of DNAME you divide it by is wrong. Instead of finding the DNAME who serve all GMC models, you use a join between serve and the car to find out the DNAME who serve one model of GMC. That gives you the dealer who serves some model of GMC, but doesn't give you the dealer name who serve all model of GMC. So that obviously is wrong. In that case, I take half points off, like 5 points off. So that's this. This is just a simple, straightforward application of division. Okay? Question on relational algebra. If you look at the relational algebra problems from the midterm compared to homework 2, the shopper example, I think it's fair to say the question I ask here is way simpler than the question I asked you in the homework. Okay. Moving on to the last problem, homework 3 SQL. The first one, I mean, it's so trivial. I mean, if you cannot get this right, you know, I don't know what to start. Right? So I will skip that. Of course, I do want to mention, a lot of you still made mistake on this. Not necessarily because you don't know SQL that well, it's because you're careless. For example, a lot of you forget to enforce the join condition between like and customer. A lot of you forgot to add the condition that customer from Salt Lake City, blah, blah, blah. I take some minor credit off your solution for that. The reason is I want to send you a reminder. Careless mistake at the end of the day still is a mistake. Don't take it lightly. You are going to be an engineer. Imagine if I ask you one day to build rocket for us. You say, okay, I made a careless mistake. That's easy, trivial mistake. Anybody know how to fix that. You know what? Once you launch the rocket is done. I don't care whether it's careless mistake or not. It is a mistake. At the end of the day, it's a mistake. You are engineers. People rely on you to get things right. Look at the Miami bridge collapse. I seriously mean what I'm saying, okay? Careless mistake is still mistake. There's no excuse for that. Especially for this midterm, the problem is not hard, open book, I give you sufficient amount of time. I remind you during the test, if I were you, I would do double check, triple check to make sure my solution is right. Yes, it's just a midterm, but imagine if one day it's not a midterm anymore, it's you building a bridge or something. If you don't double check, triple check, people's life gonna lost because of that. Look at the Miami Bridge. I'm sure they designed the bridge right. I'm sure the design architect of the bridge is fine. But somebody made some careless mistake in the execution of it. Big deal. So don't take careless mistake lightly, saying, oh, it's a 2 point, I don't care. Yes, for midterm 2 point, nothing, but I want you to learn a lesson from this. Moving on. Okay, you are engineers, you are computer scientists. Later on, you build app others gonna use, you're gonna make impact to others' lives. Think about it. Think about that. Okay? Now, find the name of dealer who serve all car model manufactured by Ford. There are really 2 ways of doing that. This is, again, division in its most basic form of SQL. We went over this like 3-4 times in lecture and homework rate. If you still cannot get this right, simply means that you don't care. You didn't pay attention. There's nothing funny about it. If you don't care, I don't understand. If I were you, I'm a student, I spend so much, I pay tuition dollar, I spend time. If you don't care, why you bother taking this class? It's an elective, by the way. It's not even a required class. Why you are here? We talk about division like 3-4 times at least in SQL. Yet, many of you cannot get this right. There's no excuse for that, I can tell you that. Okay? The first way of doing it is to do a group by and having. A common mistake with this approach is people forgot to enforce the condition that you count only those cars manufactured by Ford when you count how many cars a dealer is serving. Okay? So you do a join between serve and car model and check that manufacturer is Ford. So you count only those cars served by a dealer. You follow me? And then this count must equal to the total number of cars from Ford. That's it. That's a simple, straightforward application of division. The second approach, of course, is to use this to not exist block. The first level can be from serve. You can also use dealers from here, right? Doesn't really matter. It can be dealer as well, because all you care is put out the dealer name. You say, okay, I want to find the dealers. Not the first level of not exist says, for this dealer, there are no car from Ford that he or she is not serving. So this first block not exists. From here to here is to say, okay, which car model from Ford he or she is not serving, and such car model should not exist. If that's the case, you have served all the cars from Ford. So how do I find a model from Ford that he or she has not been serving? Well, that's easy. You select from cars, make sure the manufacturer is Ford. To show that a car from Ford is not served by the current dealer, all you need to show is there are no record from the serve table for this car for this dealer. That's it. Some of you using the to not exist approach get the structure of this roughly right. You know, okay, there are 2 not exist because it's open book. You copy from the lecture slides, but didn't enforce that this must link to the S dealer name from the outer block and didn't link this with car from the inner block. That's wrong. Even though you get the 2 not exist block structure right, but if you don't link this properly, it's still wrong. Question over there?
Why do you have to have S1 model equals C model? Because that seems like it just simplifies it, but it doesn't actually change the
Okay, if you don't have this, how do you show that this dealer is serving that car model? If you don't link them together, how do you show that this dealership is serving that car model or not?
Because if you you don't include that, it just selects everything that dealer serves, even if it's not forward.
Well, let me remove this. So let's start from serve. All you're saying, this is not a, as long as a dealer serve any car, it will be qualified. But the question asks for dealer serve all cars from forward.
So, okay, so my question is, what I did instead,
okay, what you did, I don't want to bother the whole class with. I can take that offline and check your solution, okay? But the point is, what you said earlier clearly is wrong. If you take this condition out, all you're selecting is all the cars served by a dealer. And you check that's not like this. What you're telling me is, not like it's true if that's empty set, meaning that a dealer serving no car at all will be returned, which is clearly wrong. Okay, if you don't understand that, that means if you don't see that, then you didn't understand join in my opinion, right? But if you don't have that condition, you are selecting basically everything from serve, and you say not like this. And not like it's true when that's empty. As long as that dealer serves something, it will be false, which is wrong, obviously. But that being said, taking this out obviously is wrong in this context, but your query might be slightly different from this. But I don't want to bother the whole class with that. It's not that I don't want to honor your request, but we can take that out. Okay. Well, I hope you at least understand in this approach, you take that.
I get that.
Okay, cool.
I just noticed the minus slightly different. So
okay, sure. Yeah. We talk about that all the time. Okay, the last one. Find the name of a customer who visited that dealer the most number of times. This is kind of like asking you to do that question from relational algebra using SQL. Same question, but do this using SQL. The really two ways of doing this is actually a fairly straightforward query to write. The first one says, okay, sure. Leave it. Based on your last name. No, check your last name. The first one says, okay, you go basically linear scan the visits table. You print out the D name and customer name. You need to print out both of them. You say the number of visits for a given visits record from here to here must be the maximum for any person who visited that same dealership. That's it. It's not that complicated. You linear scan through, as I've said multiple times, the way you understand that security is kind of like a for loop, right? For each visits record, check against this inner block where the number of visits from the current visit record must be greater than all the visits to the same dealer. In that case, you must be the customer who have visited that dealer the most number of times. The return customer name and D name. That's it. Okay? You don't even need to have group by, having, and all that complicated construction. That being said, this problem, the way it's constructed, the first look at this problem will trigger you to think about using group by and having, because it asks for each dealer, find the customer name. Sounds like you should group by the dealer name and the customer name. Some of you did that, fine. If you want to use group by, that's okay. First of all, because you are projecting out D name and C name, you need to group by D name and C name. You cannot just group by D name or group by C name. Either of those are wrong, completely wrong, by the way. For technical purposes, I also group by number of visits. The reason is, in order for any attribute to be used by your projection list or by your hiding clause in a group by, it has to appear as part of your grouping attributes. However, in this case, because D name and C name is the primary key of the visits table, group by D name and C name is the same as group by D name, C name, and number of visits. The effect is the same. It's just a technicality. So that I can use number of visits in hiding so that it is greater than all the number of visits from the same dealer name. Many of you have some structure similar to this, but do not have this where condition in the inner block. Then it's totally wrong. What you are saying is number of visits must be greater or equal than visits to any dealer, not to this particular dealer. That's not what the question is asking for, which is completely wrong if you think about it. You do not have this join condition in the inner block. Some of you go to the other end, which is too restrictive. You join by D name in the inner block with the outer block, as well as C name. then of course it's wrong, because you're checking this customer record to that dealership to his own or her own record to that same dealership. This greater or equal than will always be true. So every single customer to that dealer will be returned. You follow what I'm saying? Okay. That means any question on the meter?
Just scroll up a little bit so I can take a look at the.
Which one? Division?
No, just the one right above that.
The first one. Okay, sure.
Yep.
Think about this as a for loop. You're looping through each visit record, and for each visit, you're checking the number of visits must greater or equal than all number of visits by other customers to the same dealership. That's all it does. Okay? So that's midterm. Midterm, in my opinion, as I said last time, now I have gone over the solution, is really, really straightforward. If, that's a big if you have paid attention to my lecture, if you have done the homework, even if you haven't done the homework, I think you can still score 100 for the midterm. All you need to do is do some revision before taking the test, understanding the solution to the homework. You will still be able to score 100. And if you're careful during the test. So I think it's fair to say I should expect at least 80 points or above. Maybe 90 points or above. Right? If you score below that, that basically means you're not paying attention. You didn't do your fair share of effort in preparing for the test. I mean, preparing for the test is really a minor issue. Honestly, I don't care how much you get in midterm and final. What I do care is later on, when you graduate from my class, you go out work for some company or agency in Utah or some other place in this nation, and you claim, oh, I took this class from Feifei, I know database, and you end up screwing up the applications. That's when I care. When that happens, don't tell others, you can claim you know database, but don't tell others you took database from me. No, seriously, because that damages my reputation. You can claim you are expert in database, but don't ever tell others you take database from me. Okay? All right. I hope you get the bigger point. The bigger point is we are here not to get A or B or C at the end of the day. That's not my objective. My objective is to facilitate you to learn so that you can be a useful and a strong database person in your career later on. Maybe you don't end up working as a database developer or DBA, or you don't end up working with database at all. But the underpinning message, the principle we learn from here, if you think about it, the logic reasoning, how to reason about constructing a query, how to reason about normalization, get rid of duplicates and all that. That kind of logic deduction, the ability to think rigorously, that carry out to anything you do in your life. You go beyond just database. Of course, database is so important because all applications arguably build on a database of some sort. If you mess up the database, no matter how well you do your higher level application code, you got garbage in, garbage out. Right? So if you end up working for database, you better make sure you know this stuff you're doing. If you think you are not confident or not knowing that, better don't touch it. So that's the purpose of this course. Right? I'm here to help you learn, but as I said, the French cartoon picture I showed you, right? I wish that model exists. Unfortunately, technology is not advanced enough for me to just grant for like every lecturer just come here and roll the machine, that's it. But that doesn't exist yet. So it's a two-way street. You have to pay your fair share. If you don't pay your fair share, there's nothing I can do. Okay? There's nothing. I can be as helpful as you wish. I can do whatever I want. Like do all the things I want to do, but learning is a two-way street at the end of the day. That being said, I think it's fair to say the average is 81.6. So vast majority of the class did pretty well in the test. Right? So you should keep up the good work and try to do the same for the final. The final gonna be the same deal, no trick. My course is really straightforward, no trick, no curving. If you pay just a little bit of attention in lecture and do your homework, you will easily get B plus A minus A. No trick. Right? Final gonna be the same. open book for homework 4 and 5. That's essentially the scope gonna be the scope for final, and cover only the second part of the course. It does not start from the beginning. Right? Okay, any question on the midterm? Not, TAs, can you collect the midterm back from the students? All right, so that's midterm. I'm gonna now talk about homework 4. Okay? We just cannot be done with solution. Okay? Let's go over solution to homework 4. Okay, solution homework 4. Homework 4 is really interesting, right? It's about proof, right? So you have to be good at discrete math, you have to be good at logic reasoning and all that. But the good news is everything I asked you here, I covered in lecture. So if you're not sure about a question, if you go back to the YouTube video, you will find a segment from our YouTube lecture where the solution was given out. If you don't trust me, you can challenge me, you can play a game. I can show you exactly from what minute to what second on which lecture to what minute to what second covered this. Okay? I'm not confident. Okay? So if you're not sure how to solve a problem, which basically means you didn't pay attention in lecture. Okay? Or you didn't go back and review the YouTube lecture. Okay? That being said, the first one is, if it's one of the 3 basic rules, you need to prove by definition, because that's basic rule, right? I mean, there are no other theorem or fact to leverage on. You can only prove this by definition. I show the problem itself rather than the solution. I will post this, by the way, on Canvas. First one, by definition, A determine B basically means, I don't think I want to go over this because this is covered, right? 1, 2, the first one is definition. It's from the slides. I think I went over this proof during lecture. Okay? The second one is to use augmentation and transitivity. That's it. Because it's not one of the basic rules, now you can use basic rules to derive this. The last one deserves some discussion, which means that if you have A, B determine C, it does not tell you A determine C nor B determine C. This, you have to prove this by contradiction. To prove something that's true, you cannot just use one particular instance where it is true to show that it's true. However, to prove something that's not true, you just need to find one instance where this is not true. Right? So it's kind of like you claim Duke wins all the playoff games. How to prove that? Well, they just lost, right? You just need one instance. Even if they won all the other games, I don't care. There's one instance where Duke had lost. On the other hand, to show that Duke had won all the game, you cannot show like 100 games where Duke has won the game and claim Duke will win all the playoff games. That doesn't hold. You follow the rationale here? So this is called proof by contradiction. So to show this is not true, all you need to show is construct one instance where the condition given holds, but the claim you try to show doesn't hold, which I did here. Okay? A, B determine C holds on this instance, but A does not determine C. That's it. Okay? Question on this? A, B determine C holds, obviously, but A does not determine C in this case. Same value of A leads to different value of C. 2, again, I don't want to go over every single one of this because, you should go over the solution yourself and come back if you are not sure about a particular solution. But let's look at just the first one together. An employee may choose how many hours he or she likes to work on a project on any given day, true or false. This is false because there's a functional dependency E determine J, which means an employee works on only one project. And EJ determine H means that an employee works the same number of hours on the same project, no matter on which date. EJ determine number of hours. Even for different dates, this still holds. Does that make sense? So for the same project, you always work the same number of hours per day. You don't have a say to decide how many hours you work on different days, because EJ determine H. Okay, that's one example. And there are other ones I will show you another example. This is using the functional dependency to derive the statement in the specification. What about going from the other way, which is given a statement from the specification deriving the functional dependency, which says all employee, so the last question of this problem says, all employee works on the same project on one day must work the same number of hours on the date. Note that this is different from problem 1, which is the same employee for the same project, can he or she determine how many hours he or she works on that project on different days. Here is, all employees working on the same project must work the same number of hours. So it's different from that problem 1 that we just went over. Is that clear? Meaning, if I work on project 1, another person on project 1, the two of us need to work the same number of hours, no matter what. How do you express this using functional dependency? Well, you use J and D determine H to capture that. What is that? Can someone explain to me why this captures the given constraint?
Because employees are already pointed to a project, all employees, so you would only need the project and the date to point to.
Almost right, but you actually don't need that condition E determine J.
Oh.
This by itself guarantee this. Because what it says is, if the project ID is the same, and date value is the same, number of hours is the same. Whether an employee work on multiple projects, who work on this project is irrelevant, I don't care. As long as project ID is the same, and date is the same, what that means, for the same project on the same date, our value is always going to be the same. This condition itself is sufficient to enforce that statement.
What's the translation of EJD in this case? If you were at E, what would it be saying?
Huh? Okay.
What would that mean?
That's what you're asking. Can someone help me with this?
Well, if you add an employee to that, it would just mean that the employees can have different number of hours.
Say again?
Employees with projects and dates could have different number of hours.
So if you add employee to this, and project and date, what that means is for the same employee under the same project and the same date, the hour is the same. Which basically means there are no other entry in the same table to show that employee worked for that same project on the same date for different hours. This is to prevent the case, for example, I have multiple entries for the same employee for the same project on the same date. If you add E to this, that will simply prevent that from happening. In practice, this may happen. For example, I may work 2 hours in the morning, 2 hours in the afternoon. Why don't you document 4 hours and instead of document this as 2 separate 2-hour record each? I don't know. I work in the morning before 4 a.m. I want to be double paid for that. That 2 hours is different from 2 hours from 1 to 3 p.m. You follow what I'm saying? So there is a situation where you might need to do this. Separately document each segment of hours the employee work for a given project. But in most cases, we just document a whole segment of total number of hours you work. We do not differentiate the specific hours, whether it's 1 to 3 a.m. or 1 to 3 p.m. But if you want to differentiate that, then you may have multiple entries for the same employee for the same project on the same date. You follow that? Problem 3, the first one is the theorem from the class, which I gave the proof in the class. I gave the proof in the class. The second one is a variation of that theorem. Again, I gave the proof in the class. What's the difference? The proof for the theorem is part of the slide. I believe the proof of the second part, I show it on the whiteboard. I didn't show in the slides. But it's captured in our YouTube video. Okay? The trick is when W intersect D is not equal to empty set, The difference between the two is the view for your schema R will be different. In the first case, the schema of R will be, because they're disjoint, you can view this as something else. Whereas in the second case, you can no longer have this view of your schema because W and Z share some common attributes, right? Which is that A. What you have to view this is Z minus A and A. This together is your Z, and W minus A. This together is your W, and something else. That's the view. That's the only change. And this changed the way you show that the intersection, X intercept Y determine X or Y. This changed that slightly, but that's it. Okay. So once you have this view, this problem becomes fairly trivial. Okay. Go ahead.
Is it fine if we use prime like you showed in the class? Where
say again. What?
Is it fine if we use prime like you showed in the class? You were talking about prime itself, like just changing those name prime WA.
Oh, this A and whatever. I don't quite get. I don't quite understand what you mean by prime. Prime is the terminology people use to. Are you talking about prime numbers or what? This A is or whatever I'm using here is just a symbol. You can use B or whatever for this.
Oh,
it doesn't really matter. It's just a symbol.
Okay.
Right? It's just a symbol. You can use whatever symbol you like.
Oh, so it's just a symbol. Okay.
Now, problem 4 is to test you on the understanding of BCNF and lossless John decomposition. Okay? Again, fairly straightforward. The only thing I want to argue is to check dependency preserving. We talked about this in class. If you have R and the set of function dependency holds over R, if you decompose R into R1 and R2, how do you get the projected set of functions between F1 and F2 on R1 and R2? Well, the projection from F to here, you need to use F closure instead of just F. This is all the functional dependency. For example, F1 is all functional dependencies from F closure that involve only attributes from R1. That's the definition of the projection of functional dependencies. Okay, so as long as you understand this definition, this problem becomes straightforward, which I have a solution you can review yourself. Okay? To give you an example, if R equal to ABC and F equal to, for example, like this, if I project R1 into AB and R2 equal to AC, what's my F1? What's my F2? F2 clearly has B and C, B determines C, F1 will be empty set, and A determines C is lost in this case because of that. Okay? Because A determines C involves C, that's not part of A and B. It's lost. If I change this slightly, if I also have, let's see. If I add A determines B to it, you follow what I'm saying? If I add A determine B to it, then this will become A determine B. The challenge now is this dependency preserving? Looks like A determines C is lost. Right? Looks like. But is it really lost? How do you check dependency preserving? It's not lost because you basically are checking this. Whether this equal to the closure of this. If I union them together, I have A determine B, B determine C. From this, I can actually derive A determine C. So seemingly A determine C is lost, but actually it's not lost in this case. Using this simple example, I demonstrate to you how do you check dependency preserving, how to do projection of dependency on that, which we cover in lecture in greater details.
Just to clarify, I may have missed it. So when you split R into R1 and R2, then they inherit the functional dependencies that are relevant to them, to their schemas?
This is the definition. When you try to find out the projection of function dependency, you're looking for all functional dependency from the closure of F that involve only attributes from R1. That's how you find out F1. That's the precise definition of how to do the projection of quantum dependencies. Okay, the last one is further testing of this and your understanding of the lossless strong decomposition, which is it's basically checking this and this. All you need to know is now these two, or both of them. You can check whether it's lossless and or dependency. Okay? All right, so that's homework 4. Any question on this? No? Good. I will proceed with transactions. I think we're finally ready for the transaction, okay? Which I think is an interesting and exciting topic. Now let me set up the connection to the database because I want to do some demo of transaction in the database. Let me do that first. So actually, since we only have 10 minutes left, so why not we use the time, a little bit of time. Let's make it a revision lecture, right? Any question on phase 3? What about that? How about that instead of jumping into the detailed transaction? Because I cannot go too far anyway on transaction. So why not we use the remaining time of this lecture? I'm not going to start on transaction, okay? Since we only have a little time left. Ask me anything on phase 3. How about that? Okay, go ahead.
This might be too specific, but when you SSH into the Georgia to get the code, how do you just download like orders.jsp, orders.ql?
Okay, let me repeat the question. So you can SSH. SSH is a protocol to do secure shell connection. What that means is essentially you don't have to understand all the details, but what that means is all the communication between you and the server is encrypted. Okay, that's all it means. It's really important, by the way. If you are talking to the server sending over your credit card number, you don't want to send it over plain text value, obviously. Right? You want to make sure it's encrypted. In the web protocol, that's why there is 2 protocols. Right? You probably noticed this. Nowadays, rarely you say HTTP anymore. Most websites are HTTPS. The S stands the same thing as SSH. This S stands for the same thing. Okay. Basically means is the communication between you and the web server is encrypted through the browser. SSH means you are not using a browser. You are using a terminal to talk to the server. That's it. Secured it through encryption. Now that being explained, let me get back to your question, how do I copy or download files from the server? To answer that, there are actually a couple of leads I want to respond to you. One is, you can actually you actually don't need to download anything to your local server. You can do all the development on the server. The server I have configured in such a way that so for example, this is my home folder. Let me become root and become one of you. Now I'm one of you. The lucky first user. Okay, so I'm you. So now I enter the home folder of that person. So you see this public underscore HTML. This essentially is the home folder interface. This basically is this web folder that it is mapped to. So when somebody visits this link, the server is configured in such a way to load everything on this folder, load resources on this folder. So far so good? Now, if you go to this webnf and classes folder, you phase2 code should be here with the same package structure. If you do that, all your phase2 code now become visible to your GSP code under the public_HTML folder. What I mean is, you don't have to actually download this to your local machine. You can do all your development here. Everything on the server is configured, including Java, Java-C, Tomcat. Everything is properly configured for all of you. So you can do everything here. For example, I can just go to, I can use, for example, any editor of your choice to edit the code here directly. Okay, of course you may argue, okay, I don't like to use Vim, I don't like to use Emacs, which by the way, powerful developer tools, right? In my opinion, powerful than IDEs. Okay? But let's say you don't want to use that, you want to use some IDE, like Eclipse or whatever, right? Then you want to download your code locally. You can use something called in Unix, Linux environment, you can use something called SCP, secure copy. This is just like copy, but work on a remote server to copy things down. Just Google SCP, and the instruction is fairly easy to use. If you want to use a GUI interface for this, for Windows, there's something called WinSCP. So for Mac, I think I'm not sure about this. Maybe there's a Mac SCP. Just Google SCP GUI. You will find tons of resources for it. Okay, which if you have used FTP, file transfer protocol, it gives you an interface similar to that. Okay, so you can download the file to your local machine. Once you download the file to your local machine, in the tutorial notes I sent out, I have a step-by-step picture tutorial show you how to set up a local Tomcat server using Eclipse. Follow that, and you should be able to set up a local Tomcat instance integrated with your Eclipse IDE and do everything there. And when you're finished developing, you can just upload code to the server. That's it. Okay? Did I answer your question on that? Okay. Any other question we have on phase 3? Use the opportunity, right? If you don't ask me anything, I assume everybody is like expert on GSP. He is first, then you second. Go ahead.
So in the set of files, you compile the class files.
Yeah.
What's the difference between that and just pasting like the raw Java code into
inside the page?
Yeah.
So let me repeat the question. So first of all, you see there's this folder structure, right? And inside, this is the package. Inside the package is your phase2 code. What he was asking is, now if I go back to the order.gsp, so he's asking what's the difference of writing Java code here inside the page versus calling, for example, calling a Java class code. What's the difference of the two? No difference at all. But calling another class from your GSP makes your GSP much more modular and bug-free. So highly recommended. Do not write all your Java code in GSP. That's really messy, and for a project as our scale, you're gonna run into various bugs if you do that. Question over there? There's the GSP tutorial, and there's that announcement. That announcement contains an external link, which gives you the step-by-step GUI tutorial on setting up local Tomcat. There is also all the sample code I distribute. There's also the README file copied to each of your home folder. I think that's more than enough to get started. Okay? Tons of resources. But resources are only as good as if you look at them. right? If you don't look at them, I mean, I can give you a million of things, and if you don't look at them, it's like you have nothing to start with. Okay? Make sure you read through that announcement word by word, follow this README file, follow the step-by-step picture tutorial to set up local Tomcat. If that's what you choose to do, you can actually skip that if you don't want to set up a local Tomcat instance and just rely on our server, that's fine. Okay, any additional questions? Phase 3? Phase 3, let me talk about it. So we have a workload reduction, 75% reduction. No, 25% reduction. That's just 75% reduction. So 25% reduction, which is nice, I think, better than nothing. And what that means is, I will not give you any extension. Okay, don't come back. So save your time, save your effort. Don't send me an email. Can I have this actual extension? No. Okay, you know the answer. No extension. Okay. To be fair to the class, no extension. April. And how do you submit phase 3? By the way, you don't have to submit anything. When the deadline is up, simply stop editing or uploading files to your server folder. Everything here has a timestamp, and everything is logged. All your activity is logged. Like I can see who is working on what. Okay? Everything is logged, and everything is timestamped. By the time of deadline, stop editing or touching or uploading any files on your web folder. That's the timestamp we will use to see whether you have everything done before the deadline or not. If you try to edit any file or upload any file after the deadline, that will make the timestamp to be after the deadline. That invalidates that entry. So we will simply not looking at that in our grading. Okay, so be really careful on that. So you don't have to submit anything per se. Okay? Just make sure you upload all your files or finish editing all the files before the deadline. That's all you need to do on the server. Okay? Any other questions before I join the class today? No? Okay, see you on Wednesday.